Hi, hello everyone. Welcome to my channel. This is 𝐒𝐮𝐞𝐫 and in this video we are going to deploy a Super Mario game using Argo CD on a Google Kubernetes cluster. So here Argo CD is a declarative continuous delivery tool for Kubernetes applications and it automates deployments, rollbacks and integrate with GitOps. And Argo CD simplifies application management and reduce errors. So here you can see this is my Google Cloud console. So let's jump on to Kubernetes engine. And let's select your cluster. So here you can see currently we don't have any of the Kubernetes cluster. So let's create a Kubernetes cluster. So before creating Kubernetes cluster, I want to show you the GitHub repository for our today's video. So here you can see this is the repository. Currently we are using Argo CD-Mario. So this is the private repository. Okay. So when I'm releasing this video, I will change this to public. So inside this Argo CD-Mario repository, we have a Helm chart called Mario. So this is the Helm chart, guys. Okay. So let's open this Mario Helm chart. So inside this templates directory, we have deployment file and service file for our today's video. So when I open this deployment file, so I passed all these values in values.ml file because this is a Helm chart, right? So we need to pass all the values in values.ml file. So here you can see this is the deployment name and this is the image we are using /Mario latest. So this image I stored in Docker Hub. So this is my Docker Hub account. So here you can see this is the image I'm using /Mario. So using this image I'm going to deploy Super Mario game. Okay. So now let's come here. Let's select here Argo CD. So this is the path. Okay. So this is the Helm chart, guys. Okay. So using this Helm chart, we are going to deploy Super Mario game in Kubernetes cluster using Argo CD. Okay. So let's jump onto this Google Cloud and let's create a Kubernetes cluster. So directly select here create. So when you are going to create a Kubernetes cluster on Google Cloud, here it will display two different options. One is autopilot cluster and one is standard cluster. So if you select your autopilot cluster, you can directly give the name of the cluster and you need to give the region. By default, Google Cloud will create a Kubernetes cluster for you. Okay. So if you select your standard cluster, you need to give your own inputs. So right now I'm going to create a standard cluster. So I'm going to select here switch to standard cluster and switch to standard cluster. So first we need to give the name of the cluster. So here I'm giving the name like Mario cluster. So here name you can give whatever you want. So location here I'm going with Asia East one. Okay. So let's come to fleet registration. So let's leave this default and default pool. So here you can see number of nodes per zone. I need one node per each zone. So current it will create three nodes in three different zones, guys. Okay. So now let's leave this default. And when it comes to nodes, here you can see in machine configuration, I'm going with E2 and here I'm going with E2 medium. So it comes with 2 CPUs and 4 GB of memory. So here let's select boot disk like 30. So 30 GB is more than enough. Okay. So let's come up and networking. Let's leave everything default, guys. So security and method also let's leave this default and let's come to automation. Let's leave this default and comes to networking. So previously I created a custom VPC which is my VPC. So I'm going to select this my VPC. So I will show you that VPC. So in VPC networks you can find that VPC. So here you can see my VPC. So previously I created this custom VPC. So inside this custom VPC, I created two different subnets. So here you can see one subnet I created in Asia East 1 and one subnet I created in Asia East 2. Okay. So with netmask I created 24. So it will create 256 IP. 256 IPs, guys. Okay. So let's leave this and let's come here. And here automatically it was selecting subnet C. So here you can see subnet C is created under Asia East 1. Why it was selecting subnet C means? So in cluster basics, so here you can see region we selected Asia East 1. So that's why here automatically it was selecting subnet C. Subnet C is created under Asia East 1. Okay. So now let's come here and let's leave this everything default and security backup plan metadata futures. Let's leave this everything default and let's directly select here create. So now it takes nearly 5 minutes to create this Google Kubernetes cluster, guys. Okay. So let's open this. So here you can see currently it is in creating state. So it takes nearly 5 to 8 minutes in between. Okay. So we need to wait for that time. So after installing this Google Kubernetes engine, let's jump on to Argo CD official documentation. So this is the Argo CD official documentation. So if you want this, you can directly close this and I will open a new tab and you can directly search for Argo CD installation. Directly select like this and open this first link. So here you can see these are the two commands to install Argo CD on a Google Kubernetes cluster. Not only on Google Kubernetes cluster, you can install on AWS. That means EKS, Elastic Kubernetes Cluster, and Azure. Azure Kubernetes cluster you can install wherever you want. So here you can see first it will create a namespace called Argo CD. Okay. After that, this command will install all the pods, deployment services, replica sets, secrets, config maps, and everything related to this Argo CD in a Argo CD namespace. It will create everything in this namespace. So here you can see here it was defined hyphen and Argo CD. That means it will create everything in this Argo CD namespace. Okay. So meanwhile, let's come here. So here you can see it was creating. So let's wait for that time. So here you can see our cluster has been successfully created. So let's select your clusters. So here you can see currently it is in active and running. So this is the name we given Mario-cluster. So in this location we created Asia East one. So it is created with three different nodes. Okay. So nodes are nothing but virtual machines, guys. So let's come here and let's directly select here compute engine. So here you can see these three are the virtual machines. 10.0.2.7 and 2.9 and 2.8. Okay. So let's come here. Let's open this Kubernetes cluster and let's select here nodes. So here you can see these three are the nodes. Okay. So now let's connect to this Kubernetes cluster. So to connect to this Kubernetes cluster, you can directly select here connect and copy this command line access and okay and open here Cloud Shell. So now paste that command here and select here authorize. So now it will connect to our Google Kubernetes cluster. So now 𝐶TL get nodes hyphen o white. It will display all the nodes in a detailed format. So here you can see currently it is created three different nodes. So here you can see internal IP is 10.0.2.7 and at last 2.9, at last 2.8. So same here you can see these three are the nodes 10.0.2.7, 2.9 and 2.8. So these three are the virtual machines. So okay. So let's come here and let's say 𝐶TL get NS. NS is nothing but namespace guys. So here you can see currently we don't have namespace with name Argo CD. So let's jump on to Argo CD official documentations. So this is the command to create a namespace called Argo CD. So let's copy this command and let's paste it here and enter. So when I hit this command 𝐶TL get NS, it will display all the namespace. So here you can see now Argo CD namespace has been created from last 3 seconds ago. So now let's clear the screen. Okay. So now let's come to Argo CD official documentation and let's copy the second command. So now this command will install all the pods, deployment services, replica sets, config maps, secrets, whatever it may be. It will create everything in this namespace, Argo CD namespace. Okay. So now let's select here enter. So here you can see everything is going to create. Now 𝐶TL get ns. So this is the namespace, right? So first we created a namespace, and inside this namespace we created all the pods, deployment services, replica sets, config map, secrets, everything in this Argo CD namespace only related to this Argo CD using this command. Okay. So now let's select kubectl get pods hyphen n Argo CD. So here you can see these are all the pods related to this Argo CD. So now kubectl get deployments hyphen n Argo CD. So it will display all the deployments. Now kubectl get services hyphen n Argo CD. It will display all the services kubectl get secrets hyphen n Argo CD. So here you can see secrets related to this Argo CD now. kubectl get rs hyphen n Argo CD. So here you can see this is the replica sets. Everything has been created. So if you want to list all this in a single command, you can directly kubectl get all hyphen n Argo CD. So now it will display all the pods, deployment services, and replica sets related to this Argo CD. And here you can see stateful set also it was displaying. So okay. So now let's close this and kubectl get svc services hyphen n Argo CD. So here you can give services or else SVC, anything is no problem, guys. Okay. So now successfully we installed Argo CD. So we need to access Argo CD dashboard. So in order to access Argo CD dashboard, so here you can see you need to change the service type. Argo CD hyphen server, currently it is in cluster IP, right? So you need to change this to node port or else load balancer to access Argo CD UI. So now in this video, we are going to change this to type load balancer. So when you change this service type from cluster IP to load balancer, automatically a network load balancer will be created on Google Cloud. So if you are going to perform this on AWS, an application load balancer will be created on AWS Cloud. Okay. So now let's come here and let's select here load balancing. So currently here you can see right now we don't have any of the load balancers. So when I change this cluster IP to load balancer, a load balancer will be created on Google Cloud, a network load balancer. Yes, okay. So now kubectl edit service, and we need to give the name of the service. So this is the service name, right? So you need to copy this and you need to paste it here, and we need to give the namespace name Argo CD. So now let's change the service type to load balancer, and let's save this. Now kubectl get services hyphen n Argo CD. So here you can see Argo CD service type has been changed to load balancer, and currently external IP it is in pending state. Why? Because means in background a load balancer will be created. So let's refresh this. So here you can see a network load balancer has been created. So let's open this. And here you can see this is the IP 35.221.183.239, and we need to access with port 80. Okay. Remember this IP, guys. So here you can see when I hit this command once again. Now here you can see IP has been allocated here 35.221.180.239, and we need to access with port 80. So this is the load balancer IP, guys. Okay. So now let's clear the screen. kubectl get services hyphen n Argo CD. So now we need to access with this IP with port 80 to access Argo CD UI. And here HTTP colon slash slash, and we need to give that IP with port 80. So here you can see your connection is not private. So directly select your advanced and proceed with this IP. So here you can see this is the Argo CD UI. So now you need to log into this Argo CD. So here the initial username is admin and password. So this password you need to fetch from Argo CD secrets. So let's come here and now kubectl get secrets hyphen n Argo CD. So from here you need to get the secret Argo CD initial admin secret. So you can directly copy this, and now kubectl edit secret, and we need to give the name of the secret here. Now hyphen n Argo CD. So this is the password of Argo CD. You can directly copy this and save this file. So here you can see currently it is in encrypted state, guys. Okay, so this is in the encrypted state, so you need to decrypt this to base 64 to get the actual password. Okay, so now let's copy this. Let's save this file. Now here echo, and you need to paste that encrypted password here. Okay, it was not displaying. Let's do one thing. Let's open this. Let's copy this encrypted password, and here echo, and paste that encrypted password here, and here base 64 hyphen hyphen decode. So now here you can see this is the actual password. Up to T you need to copy, and you need to paste it here. So this is the actual password of Argo CD. So now we successfully log into this Argo CD. So now let's deploy our application. That means Super Mario game. Okay. So currently we created a Google Kubernetes cluster. In this Kubernetes cluster, we installed Argo CD. Okay. So now using this Helm chart. So let's open GitHub. So now using this private repository. So here you can see this is the private repository, right? So using this private repository, so we are going to deploy a Super Mario game using this Helm chart. So inside this private repository, we have a Mario Helm chart. So inside this Helm chart, we have all the files related to this today's deployment. Okay. So now let's open these repositories. So this is the Argo CD repository. So in order to integrate this private repository with Argo CD, you need to create a token, guys, in GitHub. Okay. So you need to create a token, and you need to give the token to this Argo CD. So okay. So let's do that. Let's open settings, and here you need to open developer settings, and directly open developer settings and personal access tokens, and here you need to select classic tokens, and directly select here generate new token, and here let's select here generate classic token, and you need to give the password and confirm, and let's give the name like Argo CD hyphen Mario, and expiry date let's give 7 days, and we need to give the permissions. So here I'm providing all the permissions: delete, read, write, user, admin. Okay, so code space copilot, this is unnecessary, guys, but I'm giving, and directly select here generate token. So here you can see using this token, Argo CD will communicate with GitHub private repository. Okay. So now we need to copy this token, and we need to paste it in our local. That means we need to store this in our local. So let's remove this, and once let's come to this GitHub, and let's copy this command. Sorry, copy this token and paste it here and save this. So let's close this. Now come to Argo CD. So now first we need to provide this token to Argo CD to communicate with GitHub private repository. So directly select your settings and select your repositories, and you need to select your connect repo, and via HTTPS you need to select, and type is Git. So here you can see inside Git repository only we have our Helm chart. So here you can see this is the repository, GitHub repository. So inside this repository only we have our Helm chart. So that's why here I'm going to select Git. So if you have Helm, you can directly select here Helm repository. So here I'm going to select Git, and project, let's select here default, and here you need to go the repository URL. So here you can see this is the Argo CD hyphen Mario repository, right? So this is the private repository. You need to copy this repository URL, and you need to provide here, and you need to go the GitHub username. My GitHub username is 𝐒𝐮𝐷. So you need to get a password. So your password is nothing but you need to generate a token. So here you can see this is the token we generated, and you need to copy this token, and you need to provide this token in Argo CD. And now you can directly select here connect. So here you can see connection status. Here you need to see successful. Then only it was automatically. That means it will be communicating with GitHub private repository. Okay. So now let's select here applications. So now let's deploy our Super Mario application. Directly select here new app, and you need to give the application name. So here let's give 𝐒𝐿-game, and project name let's give default, and sync policy let's select it automatic, and here let's select here auto create namespace. So here you can see when I select here kubectl get ns, here we don't have namespace with name Mario. Okay, so now let's create using Argo CD. Let's create a namespace called Mario. Inside that Mario, let's create all the deployment services and replica sets and everything. Okay. So here I'm going to select auto create namespace, and here we need to give the namespace name. Namespace name like Mario. Okay. So first Argo CD will create a namespace called Mario. Inside this namespace, everything pod deployment services, everything will be created. So now here we need to give the repository URL. So previously we integrated our private repository with Argo CD, right? So that's why here it was displaying this URL. So I'm going to select this repository URL, and here revision is nothing but this is the branch name. So let's come here. Our branch is main. So you need to select here main, and here path. So automatically here you can see it was detecting. In main path we have, in main branch we have Mario path. So let's select this. So inside this path only we have all our deployment files, service files and everything. So when I open this Helm chart, so here you can see inside templates we have our deployment file and service file. And outside of this we have values.ml file. So when I open this values.ml file, we passed all the values here. So service we are going to expose using load balancer. Okay. So now let's come here. Okay. Let's come down and cluster URL. Let's select here Kubernetes default service and namespace. Previously we have given Mario. So it will create a namespace called Mario. Inside this namespace, all the pods, deployment services and everything will be created. So here values file. Values files are nothing but, let's open this GitHub. So here you can see this is the value file, right? So using this value file, Helm will create all the configuration. That means Argo CD will create all the configuration. So here let's select values.ml. Inside this file only we have all the values. Okay, like deployment name, what is the image we are using, how many replicas we want, what is the service name, and what is the service type. These details. Okay, so let's come here, and everything is fine. Let's directly select here create. So now, first it will create a namespace called Mario. Inside that Mario namespace, here you can see service will be created, deployment will be created, replica set will be created, and two pods will be created. So here you can see currently it is in progress. That means progressing means currently it is in creating state. So here you can see deployment it is created, and here you can see currently service is creating. So now let's come here and let's select this command once again. So here you can see this name Mario has been created. Now kubectl get all -n Mario. Now it will display all the pods. Here you can see this is the service. So here you can see currently two pods are created. So when I open this file, so here you can see replicas we have given two. So that's why here two pods has been created. So service type here you can see load balancer. So here you can see we passed here load balancer. So that's why load balancer has been created. So currently external IP it is in pending state. Why? Because means here in background load balancer is going to create. Let's select here load balancing. So here you can see a new load balancer has been created, network load balancer. Let's open this. And here you can see 35.221.164.177 with port 80. So once let's close this. Sorry. Let's clear the screen and let's hit this command once again. So here you can see 35.221.164.77. So same, this is the IP. We need to access with port 80 guys to access our Super Mario game. So here you can see deployment has been created, replica set also created. So before opening this game, let's open this Argo CD. So here you can see now everything is healthy. Okay. So now if you want to see all the details about this service, you can directly open this service and you can see kind service, and this is the service name we have given Mario FN service. Namespace we created under Mario and we created on this time date, and type is load balancer, and this is the load balancer IP guys. Okay. So here you can see load balancer IP is 35.221.164.77. Here you can see 35.221.164.77 means this is the load balancer IP. So status currently it is synced and it is in a healthy state. So this is the manifest file of our service. Okay. So in Argo CD you can find everything. So if you want to see the same for deployment, you can directly open this deployment and here you can see kind is deployment, and this is the deployment name, and it is created under Mario namespace, and it is created on this date, and currently status it is synced, and currently it is in healthy. So this is the manifest file of our deployment. Okay, so let's close this, and same for replica set. Okay, so here you can see kind is replica set, and this is the replica set name, and it is created under Mario namespace, and it is created on this timestamp, and replicas it is created with two replicas, and currently it is in a healthy state. So this is the manifest file of our replica set. So same for pods. So currently two pods are created, right? So here you can see we have given here two replicas. So that's why here two pods are created. So if you want to see this pod details, you can directly open this. So here you can see kind is pod. So this is the pod name. It is created on Mario namespace, and it is created on this date, and it was using this image /𝐒𝐵 Mario colon latest. So this image I stored in my Docker Hub, guys. Okay. So let's keep this here. Let's open this. So here you can see this is my Docker Hub. So inside Docker Hub, I have this image. So let's open this. So these are the details. So this is the manifest file of our pod. So now let's access our Super Mario game. You can directly come to load balancer, and you can directly copy this IP with port 80. So this IP is nothing but this service external IP, guys. Okay, both will be same. And here HTTP :// and we need to give that IP and port. So here you can see this is our Super Mario game. So we successfully deployed our Super Mario game Argo CD on a Google Kubernetes cluster. So let's play this. So here you can see our game is working fine. So this game will work fine, guys. Okay. Okay. So this is the so this game will work continuously, guys. Okay. So here you can see when I select ctl get all icon and Mario, we deployed on Mario namespace, right? So here you can see these are the two pods related to our Mario game, and this is the service, and we are exposing our game using load balancer IP, and this is the external IP. Using this IP and with port 80, you need to access your game, and this is the deployment, and this is the replica set. And we deployed this everything using Argo CD. Okay, so this is the final output. So let's wait. So okay. So this is the final output of our game. So our game is working fine. So I will provide this GitHub repository with you guys. So currently it is in private. So let's open this repositories. So Argo CD-Mario. So currently here you can see this is the private repository. So when I am releasing this video, I will change this to public. Okay. So using this video, you can deploy your Super Mario game like this. Okay. So and yes, that's it for today's video. So now if you want to delete this application, that means Mario game, if you want to delete this entire Mario game using Argo CD, you can directly select here delete. So when you select here delete, automatically all the pods, deployment services and replicas, everything will be deleted for this Super Mario game. So now let's do that thing. So here you can see when I select here 𝐶TL get all Mario, it was displaying everything and our game is also working fine. Here you can see currently here our game is also working fine. So now I'm going to delete this. You can directly select here delete, and here you can see this is the application name we have given. Directly copy this application name and you need to give here and directly select here OK. So now here you can see service is deleted, pods are deleted and deployment currently it is deleted. So let's come here and let's hit this command once again. So here you can see currently we have only one service that will be deleted, guys. So let's wait for that time and let's come to Argo CD. And once let's refresh this game also will not work now. So here you can see currently service it is in deleting state, pending deletion. So let's wait. So why? Because it was taking this time means currently it is in load balancer, guys. So that's why first it will delete load balancer in our Google Cloud. Then only this service will be deleted. So here you can see load balancer has been deleted. So let's hit this command once again. kubectl get all Mario. So here you can see no resources found in Mario namespace. So let's select here application. So here you can see no applications available. Okay. So this is how you can deploy your Super Mario game using Argo CD on a Google Kubernetes cluster. Not only on Google Kubernetes cluster, you can deploy wherever you want. So now if you want to delete this entire Argo CD on your Kubernetes cluster, you can directly hit kubectl get ns. So here you can see in Argo CD namespace only we deployed, that means we created this Argo CD, right? So if you delete this namespace, then everything related to Argo CD will be deleted. Okay. So now kubectl delete ns. Ns stands for namespace, or else here you can give namespace and you need to give the namespace name Argo CD -- force. So now this will not work, guys. Argo CD also will be deleted in our Google Kubernetes cluster. So this is how you can delete everything. So this command here you can see kubectl delete namespace Argo CD -- force. This command will delete all the pods, deployment services, config maps, and secrets, everything related to this Argo CD. In Argo CD namespace, it will delete everything. So here you can see this was also loading, but this will not work, guys. Okay. So let's wait. It takes some time. So here you can see it was deleted. So now when I hit kubectl get ns, it will display the namespace. So here you can see automatically namespace also it was deleted. So here you can see currently it is unable to load data. So that means it was deleted everything. After some time this will not work, guys. So now load balancer also will be deleted. So here you can see load balancer also deleted for our Argo CD. So here you can see failed to load data. So that means it was gone, guys. Okay. So let's close this. Okay. So I will provide this GitHub repository in my video description. Okay. And yes, that's it for today's video. And if you like my video, please do like, share and subscribe to my YouTube channel, guys. And see you in the next video and bye.